So this is a GCSE exam question which looks at 3 circle theorem diagrams, and instead of asking us to work through like the IGCSE papers do, work through identifying the angles with the 3 letters here, you can see they've given us algebraic notation, which tends to help students. It makes things less confusing as we're working through. So we've got x here that we've got to find. In the second diagram, part B, we've got to find w, and in the third diagram, part C, we've got to find this y angle up here. Okay, well, let's have a look at the examiner's remarks. They say that part A of this question was quite well answered, so this one here. In part B, though, although many gave the size of the angle correctly, most of those students didn't know the reason. In other words, they couldn't name the theorem. So part B, we need to remember we've got to give the theorem to get the full marks. In part C, many were able to make a start by knowing the 90-degree angles or by calculating the angles at the centre of the circle, but significant numbers made no further progress. All right, so part C was a bit tricky. Let's have a look then at how we answer each one of these and go through them in turn. So for part A, we've got P, Q, R and S points on the circumference of a circle, so we've got a quadrilateral. We've got to work out the size of angle X, and it's only worth 1 mark. All right, well, angle X is opposite this angle here, PSR. So angle X is opposite an angle in a cyclic quadrilateral, and the angles in a cyclic quadrilateral sum to 180 degrees. Now we don't need to give the reason here, the theorem that we're using, but we do need to calculate the answer. So if we write down what we know that angles in a cyclic quadrilateral that are opposite sum to 180 degrees. So we know that x plus this angle here, 124 degrees, add up to 180 degrees. So it's a simple algebraic rearrangement. If we subtract 124 from both sides, we end up with x equals 180 degrees minus 124. So 180 minus 124 is the same as 80 minus 24, in other words 56. Just to check we've got the right answer here, we're going to add that back. So if we add, we've got 100, add 50, add 20 gives us 170, and then the 6 add 4 gives us 10. So 170 add 10, quick mental check there, gives us 180. Okay. So that completes part A. Let's move on to part B. So it says the diagram shows a circle and a tangent at T. So here's a circle and here's the tangent at T. And it says write down, not work out, but write down the size of angle W. So this angle here, and give a reason for your answer. Well, you should be able to recognize here the alternate segment theorem. And that's when you have a triangle in a circle and it looks a bit like some people say a bit like a windsurfer heading into a sunset. But anyway, this angle here is in this segment here, okay, made by this chord cutting across the circle. So the alternate segment is this larger area here, and the angle in there is 70. And we know that they're congruent. So this angle is congruent to the angle in the alternate segment. So in other words, we simply write down that W equals 70 degrees. So let's do that. W equals 70 degrees. But we won't get our full 2 marks if we don't give the reason. So the reason is the alternate segment theorem. Okay, we'll just leave it like that. So that's part B completed, and really there's no check that we can do. The theorem tells us immediately that this must be 70 degrees. Okay, part C. So part C says AC and D in this diagram here, AC and D, are points on the circle which has a centre O. BA and BC, so we've got now BA and BC as tangents to the circle, so we can see they meet here. And so we have to work out the size of this little angle up here. Okay, now the first thing I'm going to do is just make sure that we understand what's going on here. Now this line here must be bisecting this angle here. And let's just see how I know that. Well, we know that these are tangents to the circle, and where the tangents cross at point B, that gives us a situation where BA must be equal to BC. So BA equals BC. In other words, that side length is the same as that side length. Now we know that this side length is shared, so these two sides of these two triangles are shared, so those are equal as well. And this length here is a radius. And this is a radius, so they must be equal as well. In other words, you've got two congruent triangles. The sides are exactly the same, and when the sides are exactly the same, the angles are exactly the same. So if I label that Z, Y must equal Z. And we don't need to give a reason, but it would be congruent triangles. And all the other angles must be congruent as well. And that fact is going to be important to help us solve this problem. All right, so let's go down to the angle that we do know and work from there. So we start with the 47 degrees. Okay, 47 degrees is the angle at the circumference. And so the angle at the centre is twice the angle at the circumference. Well, the angle at the centre is this one here. Okay, not this one here, but this one here. So it's twice the angle at the circumference. So 47 plus 47. So let's write that down carefully. Now we haven't got any algebraic notation here, so I'm just going to say angle AOC equals 47 plus 47, so 2 times 47 degrees, which is 94 degrees. And let's just halve that to make sure that we haven't made an arithmetic error. So half of 90 is 45, half of 4 is 2, so 45 and 2 is 47, so that must be correct. So we've got our angle at the centre, but as we've said, this is bisected by this line here. So the angle here must be half of 94, which is 47. So angle AOB is the same as this angle here, ADC, 47. Okay, now I'm just going to write that on the diagram because it's important to keep track of these angles as we go along. So this angle here now we're saying must be 47 degrees. So write that. All right, so we now need to find this angle here, and then once we've got two angles in the triangle, the third angle is going to be easy to find. So what about this angle here? Well, we've got a tangent and a radius. And so by the radius tangent theorem, we know that this angle must be 90 degrees. It's a right angle. So the radius tangent theorem tells us that this is a right angle, and a right angle is, of course, 90 degrees. So now we've got two angles in a triangle. The third angle, let's write that here. Third angle is y. So we know that y plus 90 degrees plus 47 degrees equals 180 degrees. Okay, Let's now add the 90 degrees and the 47. So that's very easy to do mentally. So it's the same as 100 plus 37. So it's 137. So we've now got y plus 137 degrees equaling 180 degrees. Subtract 137 from both sides, and then it will disappear from the left-hand side, giving us just y equals 180 minus 137. Finally then, we need to subtract 37 from 80, giving us, what's that, 43. But again, let's not trust our arithmetic. We think that's the right answer. Okay, so that y equals 43 degrees, but let's just check our arithmetic by adding it back. So 100 plus 40 plus 30 gives us 70, and the 3 plus the 7 gives us 10, so 170 plus 10 is 180, so this must be correct.